So to review this example again, now the task asks you to round these numbers to their significant figures, to a number of significant figures. So let's say that they want you to round 314.721 meters to 4 significant figures. So let's see. Now you would start counting from the left, right? So 4 significant figures, so you will start with 1, 2, so let's say 1, 2, 3, and 4. So you would end up with 314.7 meters. Now, what happened is that you would look to the number 7 immediate right. Okay, and this number is less than 5. 2 is less than 5, so you would keep this as 314.7. You would keep the number 7. You do not round up. Now what happened is that this number, you can keep this like this as a standard form, or you can rewrite this in scientific notation. It's up to you. The same thing with this number to be rounded to 2 significant figure. So again, these 2 zeros are placeholders. Okay, so they are not significant. Now, so we will start with this one. So 1, 2. Actually, we would end with this one. Okay, so 1, 2, 1, 7 here. We look immediately to that the number right after it, which is 7, and 7 is greater than 5. So you would round this number up by 1. So you would have 0.0018. Same thing, you can keep this number that way because it already has 2 significant figures, or you can rewrite this in scientific notation. The third example, you have 8,792 meters to 2 significant figure. Now, so you would count from the left to the right, so you would end up with these two. Okay, so 78. Now, right immediately after 7 is 9, which is greater than 5. So you would add 1 to 7 here. So you would have 88. Now, what happens with this number? This number is actually 1,000, right? 8,792. So if you write 88, then it's just, what? The 10th. So 88. Now, you need to have 0 holders here. You see the placeholder here. So you have 1 0, this is 100, and then if you add 1 more 0, then this number becomes 1,000. So 8,800, 8,800. Okay, so 2 significant figure, and then this is your final answer, or you can rewrite this in scientific notation. Now, significant figure rule for addition and subtraction. Now the answer should be rounded to the same number of decimal places, not digits, as the measurement with the least number of decimal places. So with addition and subtraction, you need to, the answer must be rounded to the same number of decimal places. Okay, of the least number of decimal places. So let's take a look at this example. Now with example 8, A, so you will look at the number of decimal places. So this is 2 decimal places, this one with 1 decimal place, and this one has 2 decimal places. So your answer would be rounded to 1 decimal places. Okay, so in this case, we're just going to light up the numbers. So let's say 12.52 plus 349 plus 0.0 and plus 8.24. Okay, so add them together. then you would have 6, 7 here, point, and then in this one you would have 9, you would have 6 here, and you have 3. Okay, now however you want to route to one decimal place, which is this number here, so 7. Now if you look immediately to its right, that's number 6, so you would 6 is greater than 5, so you would route 7 this number 7 up by 1, so you would have 369.8 meter. Okay, the same thing with this operation. You have 3 decimal places here and 2 decimal places here, so your final answer must be in 2 decimal places, and you can use a calculator to find the answer for this. Okay, so the answer for this would be 46.29. Okay, remember that you have 2 decimal places meter here. Okay, alright. Next, the significant figure rule for multiplication and division is different from the addition and subtraction in a way that we would route the answer to the same number of significant figures as the measurement with the least number of significant figures. So with multiplication and division, we would concern ourselves with the significant figures. So for example, we have 7.55 multiplied by times 0.34. So let's take a look at these. How many second figure here? We have 3. How many second figure here? We have 2. So your final answer must be in 2 sig fig. 2 sig fig. Okay. In 2 sig fig. So if you plug in this number into the calculator, you would have about 2.5. You would have 2.567. Okay. 2.567. Now, these are 4. This is 4 significant figure, right? This is 4 significant figure. So if you want to only route it to 2, then it would be 2.5. Now the number immediately after 5 is 6, greater than 5, so you have to add this number up by 1. So you would end up with what? 2.6. 2.6. Right? How about unit? Now you have meters times meters, so that would be meter square. Okay? Meter square. The same thing with this one. How many significant figure here? We have 3. We have 2. So if you plug this into calculator, of course you need 2 sig fig for this one, for the final answer here. And your answer, if you plug in the calculator, you would have 1.47 meters square. And because your final answer must be in 2 sig fig, 2 sig fig here, 1.4, but then the number immediately after 4 is 7, which is greater than 5, so you would round this up to 1.5 meters square. The same thing with this one. You have 5 sig fig. You have 2 sig fig, so your answer must be in 2 sig fig. Okay, and meter square divided by meter. So meter square divided by meter, so you would end up with only meter. So the answer with 2 sig fig is 0.29 meter. Okay. The same thing with this one. Meter square divided by meter, you only get meter. And then how many sig fig here? You have 3 sig fig. How many sig fig over here? You also have 3 sig fig. So your answer must be in 3 significant figure. So I have, if in my calculator, I have 18.2025 25 meter. This is number 5. Okay, sorry about that. So you need 3 sig fig, so it ends with 2, but the number immediately after 2 is 5, so you will round it up to 18.3 meter. Okay, so the next topic that we talk about is units of measurement. Now, all metric units are based on multiples of 10, so this makes the conversion of units very simple. Now, we use SI units, an international system of units, a revised version of the metric unit. So here in this case, we have length, mass, time, electric current, temperature, amount of substance, and luminous intensity. You have to remember these base quantity. Now, I want to introduce you to the metric staircase, which is very neat one in term of that you see that the base here, the relationship between the prefixes. Okay, so for example, kilo, here we have a base and the base designated as 1. Okay, so when from kilo 1000, so that would equivalent to 10 to the 3rd power. Then after that is hecto, 100, 10 to the 2nd power, so 10 square. Then we have deca, 10, and then we have base is 1 compared to these. Okay, and then when we go down to deci is 1/10 or 0.1, or in science, you can also write as the exponents of 10 to the -1. Centi, again 1/100th or 10 to the -2, and milli, sorry, this is 2, and milli 1/1000 or 10 to the -3. Okay, so if you understand this metric staircase, the conversion would be very easy for you. Now we talk about conversion factors. Conversion factor is the ratio of equivalent measurement. So here we have equivalent measurement 1 meter equal to 10 decimeter equal to 100 centimeter equal to 1000 millimeters. So these are equivalent. Now in this case we would have, so for example, I have 1 meter over, let's say, 100 centimeter. Okay, so meter is what? Meter is a larger unit than centimeter. So here this observation says that smaller number 1 and 100, so 1 is smaller than 100. Smaller number goes with larger unit. Meter is a larger unit than centimeter. And larger number goes with smaller unit. So this is a nice observation for you to check in your calculation whether you have things correctly or not. Now, when a measurement is multiplied by a conversion factor, numbers can be changed, but the actual size of the quantity measured remains the same. So, for example, if I multiply, so let's say that I have 10 centimeter here. If I have 10 centimeter here, and then I multiply by this conversion factor, and remember that 1 meter equal to 100 centimeters. So technically this ratio equal to what? This ratio equal to 1. Okay? Equal to 1. So now if I times this conversion factor by 10 centimeter, so the unit centimeter and centimeter is actually cancelled out. And then I have meter left as the unit. But then let's say 10 divided by 100, so I would have what? 0.1 meter. Now from 10 centimeter to 0.1 meter, they have what? The number change, but it's still 0.1 meter still represent as 10 centimeter. They have the same quantity. The quantity remains the same.